All right, we're looking at Chapter 2, Section 6 here on geometric proofs. We're going to talk about a couple theorems today, and first we have to say what a theorem is. A theorem is any statement that you can prove. We're going to be looking at lots and lots and lots of theorems in this book. Ideally, we would have time to go ahead and prove all the theorems that we're going to look at. Sadly, we will not be able to do that, but ideally, if you were going to go through this book at a slower pace and have more time, you would prove every theorem that we're going to talk about in this whole book. Because once you have proven a theorem, you're going to be able to use it as a reason in later proofs. And what that really means is we're creating shortcuts. If we know that we're going to have to do something lots and lots of times in the future, then if we prove it once, we can use it again and avoid having to redo every step. And that'll make more sense as we go here. But essentially, we're creating shortcuts. We're making theorems, and we're proving it once, so we never have to prove it again. First one we're going to look at is the linear pair theorem. Linear pair theorem says if two angles form a linear pair, then they are supplementary. And the hypothesis there, angle A and angle B form a linear pair. I'm actually going to change that. I don't like the way that's said. I believe it should be angle 1 and angle 2 form a linear pair. Then the conclusion would be that if they form a linear pair, angle 1 and angle 2 are supplementary angles. So to give you a visual of what that looks like, a linear pair, if you remember from chapter 1, are two adjacent angles whose non-shared ray create opposite rays. So there's my linear pair. We'll call it angle 1 and angle 2. And what this theorem says is if those two angles form a linear pair, then angle 1 and angle 2 together create 180 degrees. That's what supplementary meant. So my conclusion then, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. There we go. And that's what this linear pair theorem says. Now you may have used this in the past already, but according to the rules of mathematics, you should have proven it first. We kind of skip that every now and then, but now that we know what it's called, if we ever have to justify why angle 1 and angle 2 are supplementary, now we have a justification. Linear pair theorem. We'll look at another one here. The congruent supplements theorem. This one's a little more confusing. It says that if two angles are supplementary to the same angle, or two congruent angles, then the two angles are congruent. And that's kind of confusing to read. And like I said, I'll draw a picture in a second. But what it's saying is that if angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary, we're almost using the transitivity property, not quite, but almost, to say that angle 1 and angle 3 are going to have to be congruent. So I'll draw a picture here. If we have angle 1 and angle 2, all right, they're supplementary angles. We also know that angle 2 and angle 3 are supplementary angles as well. Draw that 3 a little bit better here. There we go. All right, so to put some numbers to this, what the theorem says is that 1 and 3 are congruent. If we go about it the long way, the measure of angle 1 is 145 degrees. If 1 and 2 are supplementary, it says right here that angles 1 and 2 are supplementary, angle 2 would have to measure 35 degrees, because supplementary means they add up to 180. It also says that angle 2 and angle 3 are supplementary. So if 2 is 35 degrees, 3 is going to have to be 145 degrees. So 1 and 3 do end up having the same measure, which means they are congruent. And with small numbers and easy numbers like this, that doesn't really seem like that big a deal. But if we start putting something a little more complicated together, if I say that the measure of angle 1 equals x squared minus 2x. And then they ask you, what's the measure of angle 3? Well, the long way would be to try and figure out what the measure of angle 2 would have to be, and then using that to find the measure of angle 3. The easy way to use this theorem as kind of a shortcut is to skip anything with measure of angle 2. We don't have to worry about angle 2 anymore, because this theorem says that angle 1 and angle 2 are congruent, which means they must have the same measurement. So measure of angle 3 is also going to be x squared minus 2x. Doesn't matter what x is. This congruent supplements theorem tells us that they have to be congruent. They have to have the same measurement. So it allows us to make that shortcut. This next one we're going to look at is kind of intuitive. You probably figured it out already, but the right angle congruence theorem says that all right angles are congruent. So any right angle is congruent to any other right angle, which makes sense because angle A and angle B are right angles, so they have to have a measure of 90 degrees. And if they both have the same measurement, they've got to be congruent. Angle A is congruent to angle B. So I'm not going to spend too much time on this one because it's kind of self-evident that all right angles are 90 degrees, so all right angles are going to be congruent. The one on the bottom of this page, the congruent complements theorem, is almost identical to the congruent supplements theorem. Congruent supplements theorem said that if two angles are supplementary to the same angle, then the two angles are congruent. The congruent complements theorem says if two angles are complementary to the same angle, then the two angles are congruent. Almost the same, except instead of 180 degrees, we're looking at 90 degrees. Complementary meant the two angles whose measures sum to 90 degrees. So angle 1 and angle 2 are complementary. Angle 2 and angle 3 are complementary. Angle 1 is going to have to be congruent to angle 3. Same idea as the second one we looked at. So I draw a picture. Here's my angle 1, and here's my angle 2, and we'll do another one down here, angle 3. Okay, put some numbers to it. If angle 1 equals 60 degrees, using this theorem, we really don't have to worry about angle 2. All we need to know that if angle 1 and angle 2 are complementary, which I'm telling you they are, and angle 2 and angle 3 are complementary, 1 and 3 are going to have the same measurement. So using this theorem, I would just say the measure of angle 3 is 60 degrees. Now if we take it the long way, if angle 1 and angle 2 are complementary, angle 2 is going to have a measure of 30 degrees, because 60 plus 30 is 90. And if angle 2 and angle 3 are complementary, 3 is going to have to equal 60, because 30 plus 60 is 90. So it does end up working out. Again, with small numbers like this, taking it the long route is not that bad. As soon as we start putting some complicated stuff in there, this shortcut is going to help you out a lot. But you have to remember it's there. It's only good if you know it's there. Okay, so that's this section, and good luck.